I think we live in a wonderful place, and you would like to understand sort of what makes this work and what are the connections and how can we make progress in understanding also where this all comes from.
You are playing a little bit to be God because you want to find out how everything started.
We have proceeded in an enormous way in our understanding of the world. So you could say, well, leave it as it is. I think we understand the world that we see around us very precisely. Yes, but in extreme circumstances, things could go very crazy.
There is some information in the sky that we can try to look at. There's some data that we can look at. And this is the cosmic microwave background. It's the image of the sky that you get from the oldest possible light that we receive.
That radiation contains information that we do not know about, that we cannot derive from our theories, information that seems to be telling us something about the very, very early universe. Whatever it is, we want to know it.
The million-dollar question for us is what caused those overdensities and underdensities in the early universe?
If we look at gravity, we understand it through the way that Newton described it, or Einstein, and those theories work very well in our immediate neighborhood. I mean, the planetary system, I mean, the motion of the planets can be described by Newton mechanics.
So if you assume that ordinary gravity works and you extrapolate back in time, then the inevitable conclusion is that the universe started with a Big Bang.
Just the fact that we start with nothing and then we say it explodes and then we get everything around us, for me is a very unsatisfactory explanation of where we all come from.
You could also say that our extrapolation back in time is incorrect, but that also would imply that we do not understand what gravity is. So either way, there's something, gravity as we think we understand it is necessarily incomplete.
So we have to figure out a new model, a new theory that encompasses everything we know about matter and everything we know about space and time into one picture. Now a proposal for that model is string theory.
Superstring theory is a beautiful mathematical scheme that claims to be able to handle the situation, but it's not quite true. There are still all sorts of paradoxes and contradictions in that theory itself. The theory is wanting. I am not happy with the way the theory is exactly formulated.
I do believe string theory is a good framework for quantum gravity, but it does not mean it will be very easy to find the particular model in string theory that corresponds to our world. There may be such a model, but it might be very difficult to find.
I think already in the 30s people suspected that there was something, or at least they realized that there was something in the galaxy that didn't make sense, because they saw that, you know, matter in the spiral arms did not quite agree with what their motion did not quite agree with what we expected from what we saw in the galaxy.
So this is a very strong indication there must be an additional source of gravity which pulls it in and which allows it to stay together.
And you know, what we've learned is that there's a large amount of missing matter out there, and it's 5 times as much as what we can account for by visible light.
We see its gravitational evidence. We see the gravitational pull that it exerts on structures, but we don't know what it is, and we call this dark matter.
There's very little known about this because, I mean, we have no way of seeing it. We haven't found it in laboratories. Most people actually think it's some particle. And that's because we're used to particles, and maybe why can't there be more particles?
You can also say, no, all that we see is all there is, but it's just a change in the law of gravity.
Well, the standard guess is that it's some particle that hasn't been found yet. But we shall see.
We've also seen evidence for the expansion of the universe, and this happens in a way which seems to accelerate, in the sense that instead of having the gravity having it contract, the expansion seems to accelerate. This is a hint of what is called dark energy.
The elephant in the room in cosmology is dark energy. For dark matter we have many ideas of what that could be. For dark energy we have none, basically.
people are piecing together some picture of the universe where 4% of the matter that we see is kind of like the matter that we know.
And now what these observations are telling us is that we're not even made of what most of the universe is made of.
If you think about the questions that we're asking, we really are asking, where do we come from?
You know, this is the ultimate principle of mediocrity in that sense, but also the ultimate principle of excellence in the sense that, you know, it's only a tiny, tiny fraction of the universe that makes the matter out of which we are composed. So we are like, you know, gems in a mountain, you know, the precious stones in a mountain.
Our image of the world around us does affect everyone. I mean, I think this is a role that science should play, and this is also why we should tell about our theories to the general public, is that once you have some image of where we come from, it also helps you sort of placing the humankind sort of in a bigger perspective.
And of course it could be that all of it is wrong and then we have to start again. But so far I think there's a lot to understand that, but it's a pretty good story.
And if that story changes, I mean, we should do the same thing and say, well, maybe there's a slightly different way of looking at this. And that will influence also the way we view the world around us again.